Hello बच्चों, now we are going to discuss about the refraction of light in a prism. So we have a prism ABC and light is coming from the left side. So let's say light is going along PQ, R, S. So light is going along the path PQRS, R and then. So light starts from P and then at point Q the light get refracted. So let's say this is the normal. And when light travel from air to glass, light travel from air to glass. Prism is made of glass and surrounding medium is air. So when light travel from air to glass, it will bend towards the normal at point Q. And when light travel from glass to air at point R, it will bend away from the normal. Okay. Now this is again normal at point R. We have two normal, N1 at point Q and 2 at point R. Okay. So when light travel from air to glass at point Q, it will bend towards the normal. And when light travel from glass to air at point R, it will bend away from the normal. So this is the 2 points that you have to remember. And now we have to find the angle of deviation, which is the angle between the incident ray and emergent ray. PQ is the incident ray and RS is the emergent ray. We have to find the angle between the PQ and RS. That is called angle of deviation. So first we are extending this line, the direction of incident ray, and this is the direction of emergent ray. So to find the angle between the incident ray and emergent ray, you have to extend incident ray and emergent ray. Okay, so we have extended incident ray as well as emergent ray, and they're intersecting at this point. So let's say the point is M, and here we have another point. Let's say that point is D. Okay, so now this angle is called angle of deviation. This is the angle between incident ray and emergent ray. Okay, now this is called angle of incidence and this is called angle of emergence. So this is called angle of refraction R1 and this is R2. Okay, so we have mentioned all the angles, I, R1, R2, E, and del is the angle of deviation and A is the angle of prism. This is called angle of prism. Now we have to calculate the angle of deviation. So let's say if this is angle I, this is angle I, this angle should also be I. Okay, keep this thing in mind. If this angle is I, so this angle is also I. Okay, now you can take same manner. If this angle is E, so this angle is also E. The whole angle is also E. Okay, if this angle is E, this angle is also E. In the same manner, if this angle is I, okay, this complete angle is I, so this complete angle should also be I. So you can understand like this. Now we are repeating the same thing again. If this angle is I, then this total angle should be I. Okay, bacho? Now, if this angle is E, this total angle is E, this total angle should be E because these are vertically opposite angles. In the same manner, if this angle is I, so this whole angle should be I because these are vertically opposite angle. Okay. So now what about this small angle? This small angle. So this angle is I minus R1. And what about this small angle? This is E minus R2. Okay. Because the whole angle is I. The small angle is I minus R1. And this whole angle is E. Therefore, this small angle is E minus R2. Okay. So these things you have to keep in mind. Okay. So now I'm gonna find value of del. First, what is this angle and what is this angle? Okay. So in triangle M Q R, angle M Q R is equals to, so angle MQR is equals to I minus R1. In the same manner, angle MRQ is how much? E minus R2. Okay. Now, by exterior angle property, in the same triangle, you can see del, which is the exterior angle, should be equals to sum of two interior angles. Sum of two interior angles. Okay. Okay. So now we have put the value of, now we have to put the value of MQR and MRQ. Okay, this is MRQ. This angle is here MRQ. Okay, so now we need to just put the values. What is MQR? I minus 1. What is MRQ? E minus R2. Okay, now just rearrange terms. I plus E, R1, R2 got del is equals to I plus E minus R1 plus R2. So this is the angle of deviation for the prism. This is our first equation. So this is the first equation. Okay. Now we need to make different kind of equations. So there is another equations. There is another equation in which we can find the relation between R1 and R2 and A. Okay. So to find that equation, what we have to do? Okay. So now we have triangle. In triangle Q D R, by angle sum property, you can write R1 2 plus angle D equals to 180. So what is the value of angle D? Angle D is equals to minus R1 plus R2. The equation second. Now this is by angle sum property. By angle sum, same manner we have in quadrilateral to R. Okay. By angle sum, what we have here? Thus, keep in mind, angle between N1 and AB is 90 degree. Okay. This whole angle is, this whole angle is 90 degree. angle plus 90 is equals to some property. So what is the value of angle D? Is 1 is angle A. This is equation number 3, and we have to combine equation 2 and 3. Now, in equation 2 and when we combine these equations, get 180 R1 R2 equals to 180 minus angle A. 180 180 will cancel out, minus minus will cancel out. So what we have, R1 plus R2 equals to angle. This is equation number 4th. Okay, so we got the relation between R1 and R2 and angle A. Now we have to put this equation number 4 in equation number 1. Okay, so now we are combining equation 4 and equation 1. From equation 4 from equation 1 and 4. So when we combine equation 1 and 4, get del is equals to I plus E minus angle A. Again, it's a very important, it's you have to remember this relation for the numericals. It often come in numericals whenever you have to find the angle of deviation. Okay, sometime it come in MCQ also. So this, they ask in MCQ, what is the relation between del and A? So this is the relation between del, which is the angle of deviation, and A. And now what we have to do next, now we can also find the condition for minimum deviation. So for minimum deviation in the prism, have, so at minimum deviation, R1 is equals to R2. R, both the angle R1 and R2 should be same, and I should be equals to E. I should be equals to E. So these two conditions shows that there is minimum deviation in a prism. And now I have to put the value of E in equation number 5, and so that we get the value of I. Okay, so I'm just putting the value of E in equation number 5. From equation 5, putting the value of E, del min is equals to I plus I minus angle A. So the value of I is del min plus angle A equals to 2I. Del min plus angle A by 2 is equals to I. This is the value of I. In the same manner, we're going to put the value of R1 and R2 R in equation number 4. Okay, from equation 4, get R1 plus R2 is equals to angle A, and at minimum deviation R1 and R2 should be equals to R. So R plus R angle A, the value of R is angle A 2. Okay, this is the value of R and this is the value of I. Now we have to find the relation between the refractive index and minimum deviation. So we know that we can use Snell's law. So by using Snell's law, by Snell's law, by Snell's law, 1 mu 2 equals to sine I by sine R. Okay. And now we have to just put the value of I and R. Sine I del min plus angle A by 2, the value of I, and the value of R is angle A by 2. Sine R, angle A by 2. These are the values of I and R. What we have did, just putting the values of, putting I and R. Okay, we have just substituted the value of I and R. So we got the relation between the refractive index and del min. Okay, now what we have to do, you can 1 mu 2 can be simplified as mu 2 by mu 1. Okay, so 1 mu 2 can be simplified as mu 2 by mu. Here we have sine del min plus angle A upon 2 divided by sine angle A by 2. Okay, now, so mu 2 is the refractive index of the glass. So take mu 2 as mu, and mu 1 is the refractive index of the air. So take mu 1 as 1. Now we got this relation. This is the relation between the refractive index of the glass and minimum deviation of the prism. Sine angle by 2. This is the final expression. And the relation between the minimum deviation and the refractive index of the prism.